All right, so slope and slope-intercept form and input today. We have a couple language of the discipline words. So go ahead and write your L/D for language of the discipline and draw your gate icon. Everybody's doing it. And the first one is rate of change. Rate of change. Rate of change. What does that mean? That basically means the change in the dependent variable. Change in dependent variable. Change in dependent variable divided by or over the change in the independent variable. So the rate of change is the change in the dependent over the change in the independent. I'm going to put or right here because I can write it also as y2 minus y1 over x2 minus x1. We're talking coordinates here. So the second y minus the first y of two coordinates over the second x and the first x. It'll make sense when we get there. Rate of change. The next word is slope. Slope. Slope, slope, slope. Now slope means vertical change divided by or over the horizontal change. So vertical change all over the horizontal change. Also known as, I'm going to put a box around that so I could see it, rise over run, like you guys said earlier. Which is also known as y2 minus y1 all over x2 minus x1. Those are all slope. So the vertical change on the graph, so going up or down, over left to right, rise over run, also known as y2 minus y1 over x2 minus x1. That's the slope. Okay. Next, we're going to have the slope of a line. Slope of a line. Okay, and I'm going to give you 4 different graphs. We'll just make them really small, okay? So the slope of a line, if it's a positive slope, your line is going to go up and towards the right. That's what it's going to look like. So that would be considered a positive looking graph. That graph is positive. It goes up and slopes like you're walking up a hill. Positive, up a hill to the right. Then you're going to have a negative slope. I'm going to draw it really quick. And then I'll show you. Everyone got the first one?
Yes.
Yes? Thank you for answering. Okay. You're going to have a slope that might go down. So now it's going up and to the left. That's going to be considered a negative slope. So you know if you look at a graph and the line is going up and to the left, that when I ask you for the slope, it's going to be a negative fraction or number. If you see the graph going up and to the right, you know that your answer is going to be positive. Think about the quadrants, right? Then you could have one that looks like this. And your line is exactly on top of the x-axis. So I'm using a different color. That slope would be considered 0. And that could be any horizontal line. If the line is just straight horizontal, I don't care if it's on the x-axis, okay, that's 0. Horizontal slope on the x-axis is 0 because on the x is 0. You're not going up, down, not going, and you're just going straight up. Okay? And the last one. If your slope is exactly on the y-axis, that slope is called undefined. There is no slope, also known as not a function. We learned about functions before. So if it's exactly on the y-axis, the answer is undefined. So if I said, what is the slope of that line? You would say undefined. If I said, what is the slope of this line? You would say 0. Okay? Next word is y-intercept. Y-intercept. What is the y-intercept? Well, it's the y-coordinate of the point where a line crosses the y-axis. So it is that point on the graph that hits the y-axis. It hits some point, the line crosses over a certain point on the y-axis. That's the y-intercept. Looks like we're taking some great notes. Awesome job. Last word, or thing that we need to know, is called slope intercept form. And that's going to be one of our main focuses today. And what slope-intercept form is in this equation, you highlight, box it, underline, whatever you need, is y equals mx plus b. That is super duper important. Y equals mx plus b. Now let me tell you what that means. Y is the y. M represents the slope. Go ahead and put an arrow and write slope. So if the slope is 1 over 1, 3 over 2, 5 over 4, that's the representative M. Put an arrow there. And then B is your y-intercept. X stays X, Y stays Y. Those X and Y are numbers you do not have to change. But B and M should be numbers. Yes? Turn to your neighbor and tell them what the slope is, slope-intercept form. Tell the person in front or behind you. So, I'm going to play you a little song. And you're going to sit and listen.
B, y equals mx plus b. There was
gonna get stuck in your
a guy
head.
named Renee looking for a new way to imagine algebra 4. So geometry went formulated his head, and the Cartesian really soon was born. Everybody sing y equals mx plus b. Y equals mx plus b. Y equals mx plus b.
Everyone sing it. You have to sing y equals mx plus b. You have to remember that form because on the test you're going to have to know them. Yep. So you get the picture. Now again, tell your neighbor what the equation is.
Y equals mx plus b.
Who can tell me what m represents?
Slope.
Who can tell me what b represents?
Y-intercept.
You guys are so smart. Here we go. Modeling. Example 1. The directions say to find the rate of change in each situation. Please write down the directions. Find the rate of change in each situation. So the first situation, they're going to give us a table. So we're going to call this situation A. The table has time and temperature. I'm going to say temp, shorten it up. Time and temperature. Under time, it gives us the numbers 1, 4, 7, and 10. And under temperature, it gives us below 2, -2, 7, 16, and 25. Now, let's label that the time represents the independent variable. And the temperature represents the dependent variable. So they want us to find the rate of change in this table. So when I find the rate of change, I'm going to find, if you go back to your notes, I want to find the change in the dependent variable first, rate of change, in the dependent variable, and then the change in the independent variable. All right, so let's look at dependent variable because that's the one that goes on top first, okay? So I need to know the rate of change between 7 and -2. So first of all, we know that this is known as y2 minus y1 over x2 minus x1. Okay, so this is my y2 over that. So I'm going to get 7, plugging it in, minus -2. That's my x, that's my y's. I got them from right here. And now I need to find the rate of change between 4 and 1 in my independent variable. So then I plug it in. 4, the second one, minus 1. And now I can solve. So what is the rate of change? That would be 7 plus 2 over 4 minus 1. 7 plus 2 is 9. 4 minus 1 is 3. 9 divided by 3 is 3. That's it. That's the rate of change. So my answer is 3. So again, what you do when you have a table is one side of the table is your independent variable. The other side of the table is your dependent variable. Okay? Take the second one minus the first one, and the second one minus the first one over each other using this equation, which is rate of change, to find your answer. So the temperature changes by 3 degrees the temperature changes every 3 hours. That's the rate of change. Changes every 3 hours. Okay? Are we good with that one? Yes?
Yes.
Okay. I'll take questions at the end. So, and you can also choose any number. I could have done 10 minus 7 and 25 minus 16. Okay? I could have done those numbers. I'll still get the number 3. So no matter which numbers you pick, but you have to do the one below and then the one on top, because it's y2 minus y1. The one below, subtract by the one on top. I could pick any number. If I picked these numbers down here, if I said 25 minus 16 over 10 minus 7, I would still get 3 as my rate of change. It doesn't matter which numbers you pick. I just picked the first 2. Okay? All right. Let's take situation B. Situation B gives us a graph. So let's draw a graph that has about, let's give it 5 squares. So I'm going to do 1, 2, 3, 4, 5. Go ahead and draw the graph with me. So this is 2 and that's 4. Negative 2, I hear talking. Negative 4. Positive 2. Positive 4. Negative 2. Negative 4. I'm labeling by 2s just so I don't have to label every single number. And my graph shows me a point of negative 2, 1. And a point of 3, 4. And my graph looks like this. Okay. Now in this case, I need to find the rate of change. Again, going back to my notes, the rate of change can be independent variables and dependent variables, but I don't see that. It can be y2 minus y1 over x2 minus x1, also known as rise over run. Okay, so I know that I can use rise over run, or I can use y2 minus y1 over x2 minus x1. I think I'm going to use the equation, but I'm going to first go back to my graph and label. So this is my x1 and my y1, and this is my x2 and my y2. So I went back and labeled those numbers. Doesn't matter which order, you'll get the same answer. So now I'm going to plug it in. My y2 is 4 minus my y1 is 1. Okay, got that. Over my x2, 3, minus My x1, oh, negative 2. So you can see where I got those numbers. So you're going to put it on the website for the rest of the notes. And bring your notes. And your workbook. So then I'm going to solve. 4 minus 1 is 3. 3 minus a negative 2 is 3 plus 2. So that would be 3 over 5. And that's your answer. Sorry, let me get David headed home and then we can continue. Okay, sorry guys. Alrighty. Moving on, does that make sense?
Yes.
Take your y2 minus your y1, your x2 minus your x1 to get an answer. Most likely you'll get a fraction. Sometimes you'll get 4 over 1, you can make it just 4. But every other time you'll get a negative or a positive fraction. Okay? Let's move on to example 2. Your directions will say find the slope of the line that passes through, and David's spelling definitions, look up the definitions, through the points, write that down in your language arts. And that's it. Find the slope of the line that passes through the points. Okay, so here's example A. They're going to give us point -2, 5, and they're going to give us 3, -4. So I'm going to write the equation first, because I know that's what I need. I know that in order to find the slope, I need y2 minus y1 over x2 minus x1. Please write that down. That's always going to be your first step, is to write the equation, then substitute the numbers in. So then I'm going to look back and I'm going to say, okay, y2, let me label x1, y1, x2, y2. First number is always x, the second number is always y. We're just putting x1 and y1, meaning that's the first one they gave us. X2, y2, meaning that's the second set of numbers. So now I'm just going to plug it in. My y2 is -4 minus my y1, 5, over, so I'm substituting the numbers in, my x2, which is 3, minus my x1, -2. So I just plug the numbers in. Everyone have that written down?
Yes.
Good. So then I'm going to solve. -4 minus 5. Same signs, add and keep the sign. So that's going to be -9 over 3. 2 negatives become a positive. 3 plus 2. So I have -9 over 3 plus 2 is 5. And that's your answer. That's it. My slope is -9 over 5. So when you have 2 points, that's what you need to do. Let's try one more like that and then move on to example 3. So we're going to call this B on this other side. They might give you -2, -5, and 4, 5. First thing I do, write the equation. I'm going to zoom right here. Sorry, it's really glitchy today. Slope equals y2 minus y1 over x2 minus x1. First thing I do is write that equation. Next thing I do is label so I can plug my numbers in. x1, y1, x2, y2. That way I can visually see what I need to do. Alright, so plug the numbers in. y2 is 5 minus y1, -5 over x2, 4 minus x1, -2. 2 negatives next to each other equal positive, so that turns it into 5 plus 5 over 4 plus 2. So now I'm going to add. 5 plus 5 is 10 over 4 plus 2 is 6. I can't leave it like that. Thinking to myself, I can divide both by 2 to reduce my fraction to be 5 over 3. 5 over 3 is my answer. On your test, if you leave it as 10 over 6, your slope will be wrong. Not that it's technically wrong, but it's not the simplest form. Everybody have that written down?
Yes.
Okay. Your note should be beautiful.
We are adored.
I shouldn't hear any voices. It's getting more aggressive. Turn around. All right, moving on to example 3. Halfway. Example 3. Please write the directions. Find the slope and y-intercept. Find the slope and y-intercept. Find the slope and y-intercept. Okay? So, we know what slope-intercept form is because they're asking us for the slope and the y-intercept. Turn to your partner one more time and tell them what the slope-intercept form is. What's that equation? Raise your hand if your partner said y equals mx plus b.
What's the y-intercept?
Awesome. Okay. Shh. So let's look at example A.
Plus b. What's the y-intercept?
They give you y equals x
What's the
plus 2.
Represents the rise over.
They give you y equals x plus 2. Well, the directions tell me to find the slope and they tell me to find the y-intercept. I remember when I was taking notes with Miss Graham, she wrote down what the slope-intercept form looks like and what they represent. Whatever number is in front of x is the slope, and whatever number is next to that in the equation is the y-intercept, where it intercepts on the y-axis. Interesting. So I'm going to say, okay, Miss Graham told me y equals mx plus b. I can match that. If this is the slope, this must be the y-intercept. There's no number in front of x. So what can the slope be? No. The slope is 1. It's that, remember that invisible 1 that's in front of the variable? Okay, so my slope is 1. And my y-intercept is 2. That number right there. That's it.
So n, our slope equals,
That's it.
our slope equals 1.
Because 1 is that, remember it's that invisible 1 that's in front of the x.
Y-intercept is 2.
So make yourself a note. I'm going to make myself a note right here. If there is no number next to x, the slope is 1. Make yourself a note. If you're like, there's no number in front of x, what do I do? Yes, there is. There's that invisible 1 in front of x. If it was negative x, what would the slope be?
Negative.
Negative what?
1.
Negative 1. If it was negative x, it'd be negative 1. Very good. Very easy. They're just asking you to identify it in the problem. Let's look at example B. They give us y plus 1/3 x equals negative 2. But wait a minute, Miss Graham. How can I identify what the slope is and what the y-intercept is if it's not in slope-intercept form? Well, student, you have to put it in slope-intercept form using simple algebra. Okay? So, what I would do first on both sides to get y by itself is I would subtract 1/3 x from both sides. Now my 1/3 x are gone, and I'm left with y equals negative 1/3 x minus 2. Whoa, everybody see that?
Yes.
It's simple algebra. All you have to do is just get it to the equation that it was. Now I can identify what the slope is, and I can identify what the y-intercept is. Okay, easy. So Miss Graham tells me y equals mx plus b. What's my m in this equation? The number that's next to x,
Negative
and
1.
b is the other number. So my slope is negative 1/3. That's the number that's in front of x. And then my y-intercept is it 2?
Yes.
Just 2?
Negative 2.
Negative 2. The reason that we just wrote 2 here is because I'm not going to write plus 2. Positive 2 is 2. But this whole answer with the negative is negative 2. That's it. You've identified what the slope is, and you've identified what the y-intercept is. Easy peasy. All right, I'm going to show you one more example of that, and then we're going to write the steps right next to it so that we have that. Example C, in the same one, y plus 3 equals negative 1/3 x. So right next to it right now, I'm going to write the steps, and you're going to write the steps too so you have them at home. Okay? So step 1, we need to isolate y, or get y by itself. Well, How am I going to do that? Oh, I need to subtract 3 from both sides. Positive 3, negative 3 cancel. Y equals negative 1/3 x minus 3. Beautiful. I did step number 1. I isolated y. Y is by itself now. Step number 2. Identify.
Miss Graham, can I ask a question?
Sure.
Why can't we take away 3 from 1/3 x?
Ooh. Why can't we take away 3 from 1/3 x? Why? Are they like terms? So can you subtract? So why? Because they are
Like terms.
They are not like terms. Do we all understand? That's a great question, Mrs. Bernstein. They didn't even know. Identify the slope. Okay? And the slope is next to x. I know that. Okay? So I know that the slope, because I know that slope equals y equals mx plus b. The number next to x, my slope is what? Negative 1/3. And my y-intercept is 3?
What? Negative 3.
Negative 3. So my last step was to identify the y-intercept. That way I know when I get home, I'm going to isolate y, get y by itself. I'm going to identify the slope. And remember, when you isolate y, you can't subtract 3 from whatever the slope is x, because they are what? Not like terms. Very good. And then you identify the slope, the number or fraction that's next to x, and then the y-intercept. Okay. I'm going to smooth that up a little bit. Example 4. And remember, I give you different types of examples because they ask you these types of problems in different ways. So you need to write down every way so that you go, when you get home, you're like, I don't know how to do that kind of problem. Let me go back in my notes and find a problem that's exactly like that one so that I know the steps to solve it, okay? This is write an equation using the given information. So it's like solving a puzzle. They're going to give us some information, and we need to take that information and put it into an equation. I think I can do that. And what's the equation I'm going to put it in? What slope-intercept form?
Y equals mx plus b.
I didn't hear everybody. What slope-intercept form?
Y equals mx plus b.
Okay, so that's what I need to put it in. Very good. So let's see. What information did they give us in example A? They're telling me that m is 4 and b is 8. They give me m, which represents slope, and they give me b, which represents my intercept. So I'm going to write the equation down. Y equals mx plus b. That equation is going to be in your head all day. So now I just need to substitute in those numbers, right? Y equals m is 4, x plus b is 8. Done. Is that easy or what?
Yes.
Super easy. You're just substituting in the information that they give you and putting it in that slope-intercept form equation. Y equals mx plus b. Now this one's going to be interesting. Let's see what you think. M equals 4 over 3 and b equals 0. 0. How's that going to look? Well, let me write the equation first. Y equals mx plus b, and then I can plug it in. Y equals m, which is 4 over 3. That's what the information they gave us. Bring down my x, plus 0. Looks kind of funny. When you write this equation, plus 0, you do not need it at the end. Drop the 0. So your final answer is y equals 4/3 x. Just like that. You don't need the plus 0. Because 0 is the y-intercept. That just tells you where the line passes through the y-intercept. It passes it through at 0. And the line goes through 0. Pencil up when you have that. Thank you. Okay. Let's try one more. M equals -1/5 and B equals -3. Again, write the equation first. Y equals mx plus b. Okay, so now I can substitute in what I need. Y equals m. M represents -1/5. -1/5. Bring down my x. X. Plus b. Now watch. And this will be an aha moment. Plus b is -3. Now the reason why I was asking you before if it was a positive or -3 when you're writing it down is because of this reason. When you plug it in the equation, if I have a positive and a negative operation next to each other, what does that operation become?
Negative.
Yes, -3. Does that make sense? Why now?
Yes.
Yes. Very good. That's why if you ever got an equation that was just like this and they asked you to find the slope-intercept form, it's -3 because it's plus -3. So that sign is negative. All right, example 5. Perfect for a rainy day. We have a lot of math to do. Now this example says determine whether the ordered pair lies on the graph. Please write those directions down. Determine whether the ordered pair, so we know we're going to get a set of numbers, x and y, lies on the graph. You're like, how are we going to do this? Trust me, it's very, very simple. Okay, they're going to give you an example that looks like so. You're going to get, let's see, 2, -7, and then they're going to give you the slope-intercept form. Y equals -3x minus 1. So they give you a point, and then they give you the slope-intercept form. Now watch what you do. Step 1, which I'm going to write over here. You substitute x and y. Step 1 is to substitute in x and y. So look, I'm going to identify, okay, here's y, so that's where I'm substituting. Here's x. Does everybody see that? So I'm substituting these numbers in on the points for x and y. I can do that. Okay, so y, -7 equals -3. My x is 2, so -3 times 2 minus 1. So the first thing I did, step 1, I substituted in x and y into this equation. I put those numbers in that equation. Now, step 2, which is very simple, is to solve. So I'm going to solve. Okay, here's negative 7. I'm going to solve on this side. Negative 3 times 2 is a negative 6 minus 1. Negative 7 equals negative 6 minus 1. Same signs, add and keep the sign. Negative 7. Does negative 7 equal negative 7? Yes. So that means that the point lies on the graph. If you plug in x and y into the equation and those numbers equal each other, yes, it's on the graph. If the numbers are not the same, it's not on the graph. Yes or no answer. Super, super simple. So please write down step 3, which is going to be our note to ourselves. If the solution to the problem is the same, comma, it lies on the graph. If the solution is the same, it lies on the graph. Okay, so now you have your steps here. So when you get home, you know exactly what to do. So let's try another one. Negative 7, negative 6, and they give us the equation negative 6x plus 5y equals 12. Ms. Graham, that's not in slope-intercept form. Can it be? Yeah, sure it can. But do we need to change it? No, because we're just plugging in x and y. So again, identifying that this is my y. Some of you are going to make that mistake and plug in your x for the y. Make sure you do the right number. And my negative 7 is my x. Okay? So I'm going to plug these numbers into this equation over here. So my negative 6x plus 5y equals 12, I'm going to plug in those numbers. So negative 6 times x is negative 7 plus 5, my y, times negative 6 equals 12. So we want to figure out if our end result is going to be 12 equals 12. Let's see. Negative 6 times negative 7 is a positive 42. Plus negative 6 times 5 is negative 30 equals 12. Uh-oh. I have a plus and minus next to each other, so the operation is going to be positive or negative?
Negative.
Negative, good. So that turns into 42 minus 30 equals 12. Well, 42 minus 30 is 12. So does it lie on the graph? Yes.
Yes.
So my answer is yes. Very, very simple. Okay? Last one in this example, and then we have one more example and we're done. I know we're doing 2 sections, it's one of those days. Oh, sure. We can write the next one down as 8, 4, and then the equation is 3y equals 2x minus 1. Now I'm going to let you try this one. Let's write it down, please. I want you to try it. You're good? those who are sitting there, that means you're already done. I want everyone to try. Take 2 examples that you just wrote down to help you. Texas, please welcome. This is good. That's okay.
Why, thank you very much. You have a wonderful day.
Okay, let's see what happens. So, my smarticle 8th graders know that they need to plug in y with y and x with x. So I have 3, my y is times 4, equals 2, my x is 8, minus 1. Did we get that far? Yes?
Yes.
Okay, so 3 times 4 is 12, equals 2 times 8 is 16, minus 1. So 12 equals 15. Does 12 equal 15?
No.
No. So does it lie on the graph?
No.
No. That's all you gotta do. Make sure you have that written down if that's what you did not get. So you have the correct answer written down. Please and thank you. Yep, we're just to the graphing section and then we'll be done. Okay. All right. Example 6. Before we move to example 6, okay, everybody just stand up and stretch for 30 seconds.
Yay.
30, 29, 28, 27, 24, 23, 22, 21, 20, 19, 18, 17, 16, 15, 14, 13, 12, 11, 10. Start sinking back into your seat. 9, 8, 7, 6, 5, 4, 3, 2, 1. We made it. All right. That was 7th inning stretch. All right. Graph each equation. What? I have to graph? Yes. So graph paper might be your friend. Yes. This is the last example. Oh, yes.
Oh my God.
I told you we're doing 2 sections in one today. Happy rainy day. Shh. I want to give you as many examples as possible so you have no issues when you get home.
Your homework will be so easy. Easy.
I'm writing just as much as you are. All right. So we have y equals 2/3 x plus 3. Okay? So, when you do a graphing problem, you need to examine that equation. Find the slope, find the y-intercept so you're able to graph. Okay? So step number 1, we're going to write it on the side, is what I just said. Identify the slope and y-intercept. Identify the slope and y-intercept. Okay, I can do that. Slope. Y equals mx plus b. So my slope is what? 2/3. And my y-intercept is 3. Simple. I just did step number 1. I looked at that problem and I said, what's that number next to x? What is m, the slope? 2/3. And then what is it? cross on the y-intercept? Positive 3, so I put 3. Okay? Step number 2. Draw a graph. Draw a graph. Now for me, this is how I estimate. Well, if the number passes through 3, I'm going to make my graph about 6 or 7. So I'm going to draw a graph. So I'm going to do about 7 squares. You're drawing with me. I have completed step 2. I drew a graph. Now I need to label. 1. I'm going to label by 3s. I don't have to label every number. 3, 5, 7. Positive 1, 3, 5, 7. Negative 1. Negative 3. Negative 5. Negative 7. And then I have negative 1. Negative 3. Negative 5. Negative 7. You can label by 2s. You can label every single number. I'm just going to label by odds, by 3s, or 1, 3, 5, 7 odds, because I know that the y-intercept that it crosses is 3. Now this is very simple. It's simpler than you think. Step number 3, you're going to place a point or a dot on the y-intercept. What? Yes. You're going to place a dot on the y-intercept. So the y-intercept is positive 3. Do I put it over here?
Yes.
What line is this? This is the x-axis, everybody. What line is this?
Y.
That's the y-axis. The y-intercept, do I put it over here?
Negative.
No, I put it on the y-axis. So I'm putting a point on positive 3. Does that make sense? So the y-axis, the point you're going to put it on, is that vertical axis. Okay? Last thing I'm going to do, step 4, is count the rise over run, or the slope. So I'm going to start at that point that I identified. Everybody see that? And I'm going to count my rise over run, which is my slope. Positive 2 and 3. So my rise is 2. My rise 2. 1, 2. My run is 3. I go to the right 3 because that's positive. 1, 2, 3. Put it on. I can do it again. I rise 2. I run 3. So then my line looks like this. My goal for you is to draw at least 3 points. Because if you draw at least 3 points, you know where your line's going to go on the graph. So your rise is either up or down. So that first number in the slope is positive 2. So positive means I go up 2. If it was negative 2 over 3, I would go down 2. Then the second number, the number on the bottom, is my run. I'm either going to run to the right on the graph, which is positive, or to the left, which is negative. Both of these numbers are positive 2 and positive 3, so I'm going up and to the right, up and to the right. Okay? Does everybody kind of understand? Kind of, sort of?
Yes.
Yes? Okay, one more then. If you said no, I would have done more. Here we go. Y equals negative 0.5x plus 5. There's gram, there's a decimal. Do you know what 0.5 means in fractional form? Half, right? So let's rewrite that for ourselves. Y equals negative, What's 0.5?
Half.
Okay, so negative 1/2 x plus 5. So we just rewrote it with the fraction. If it was 0.75, what's that as a fraction?
3/4.
3/4. If it was 0.25, what's that as a fraction?
1/4.
1/4. Okay, so we know how to do that. So now I'm going to go back to my steps. Step number 1 tells me to identify the slope and y-intercept. Okay, so slope equals, everybody on the count of 3, what is the slope? 1, 2, 3.
Y equals mx plus.
No, not slope-intercept form. On the count of 3, I want you to tell me what the slope of this equation is. 1, 2, 3.
Negative 1/2.
Very good. Now I need to identify the y-intercept. On the count of 3, everyone please tell me in this equation, what is the y-intercept? 1, 2, 3. 5. Beautiful. Step number 2, draw a graph. I'm just going to put my graph to 5-ish, you know. So I'm going to put it over, I'll put it below so you can see. So I'm going to go with 5 squares, 5 squares, 5 squares. And of course on your homework you're going to use a ruler. Don't draw straight as I do. So, these I'm gonna go by 5. So this is 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Negative 1, negative 2, negative 3, negative 5, negative 1, negative 2, negative 3, negative 4, negative 5. I need everybody to have this graph on their paper. It's the last graph we're drawing. You can do it. Okay, so I completed step 2, which is draw a graph. 3, place a point or a dot on the y-intercept. What's my y-intercept?
5.
5. Do I put it over here?
No.
No, vertical only, because this is the y-axis. So I have a point on 5. Let me go back to my slope, because now I need to figure out what the slope is. It's negative 1 over 2. Negative 1 means I go up or down? Down. So I'm gonna put down right here so I remember. I'm gonna go down 1. Positive 2 means do I go run to the right or left? Right. Right is positive on the graph. The right is positive on the graph. So I'm going to go down 1 to the right 2. Here we go. Down 1 to the right 2. Put a dot. Do that. Down 1 to the right 2. Put a dot. Put at least 3 dots, but I'm going to go one more. Down 1 to the right 2, just to make sure my line is straight. And then from there, you're going to connect the graphs. Yeah? Go ahead, Alex, when you're ready.